they bought 4 of our battery packs for that exact problem, charging electric vehicles. Where in one neighborhood, when the first thing is apparently when one neighbor buys an EV, like I don't know the exact stat, but like it's hundreds of percent more likely that your neighbors will start buying another
Yeah.
EV as well, and everybody's following suit. And when a neighborhood there are 10 people all charging their EVs at home at the same time, that neighborhood grid is also about to black out.
Right.
So it's because the current transformers and infrastructures can't take that high power draw. So for Ottawa Hydro, rather than spending millions of dollars in uprooting the transformers and the current infrastructure, they spent a couple $100,000s to
Right.
install a couple batteries to, again, during when everybody's charging their EVs, we can also discharge our batteries so that we can supplement
Yeah.
the grid.
Hello and welcome to EVfriendly. I'm Ken Hendricks, and this is the podcast for you if you're into engaging conversations about electric vehicles. On today's episode, we are talking with Eddie Chiang. Eddie is a co-founder and CEO of Moment Energy, which is a Vancouver-based clean tech startup creating sustainable and affordable energy systems from repurposing batteries from electric vehicles. In 2021, Moment Energy was a recipient of the Advanced Research and Commercialization Program grant from the Ministry of Energy and Mines, and they were also the grand prize winner of the 2021 National Impact Investor Challenge. Eddie, welcome to the podcast.
Hey, thanks for having me.
Great. I always like to begin. Tell us a little bit about yourself and how you came into this market.
Yeah, for sure. So started this company over 2.5 years ago. Started with my 3 best friends. So all 4 of us, so Samarine, Gabe, Grimesh, and myself, Eddie, we all went to Simon Fraser University. And we all studied mechatronic systems engineering out there. And together, we've been best friends when we just started the company, January pre-COVID, 2020, pre-COVID. We had been working together for 6 years already. We worked on things, for example, we all co-founded a Formula Electric race team. So built and designed an electric race car from scratch out there. And the goal was really just to race our electric vehicles in either long duration challenges or even in speed. Now, the moment we were ready, COVID hit. So unfortunately, we had to do an online race competition, which was weird. But the team won, which was great
Cool.
on the business presentation, which was pretty cool. But then through that, like learning about electric vehicles, and then as, for example, Gabe, our CTO, he worked at Tesla. Samarine, our COO, worked at Apple. And then myself, I've done nuclear energy research for the Canadian government as well, north of Ottawa. We really grew our passion for clean tech and electric vehicles. So for me personally, getting into this energy space, when I was working at the Canadian Nuclear Laboratories, 2 hours north of Ottawa, this was in September 2018. A tornado hit Ottawa, so they were out of power for 4 hours, which is pretty long for a big city. But being connected to their grid, we were out of power for 24 hours. And that was shocking as somebody that comes from Vancouver, and our outages last for 30 minutes, really.
Yeah.
And then I asked around the locals, and this was like a local town of, they claimed 3,000 people, but it was probably closer to 1,000, 1,500. And the people who grew up there said, oh yeah, this is like a short outage for us. Like yearly, we experience up to a week in outages. And the worst that they've even heard were, especially as you go a little bit more north too, 2 whole weeks without power. And that was
extreme.
eye-opening.
It's extreme.
Yeah.
Even the last storms that they've got, I think
Exactly.
it was a couple weeks.
Yeah, and I just didn't realize like Canadians experience that, right? And if Canadians 2 hours away from our capital experience that, you could just think about like other countries that aren't as fortunate as we are. So that really instilled the passion in myself, but also our team to solve this issue. And the first part is one, to make sure that every human has access to clean, reliable power. But then the other aspect is with our passion in electric vehicles, we really saw this problem. It's really great that we're transitioning into electric vehicles and decarbonizing transport. But, people always say that there's a caveat, right? Like, oh yeah, EVs are great, but what happens to the battery at end of life. And we dug in deeper, and we saw that there's a problem, and that we can definitely address that.
Well, that's what makes EVs unique out of all the product life cycles, because it has this interim period, where it has a natural life and with the battery, and it could be used, it can be repaired in many instances, but it's not all of a sudden then to recycle. It has this, what we call a second life, which is often referred to it, and that is where secondary energy storage really comes into play.
Exactly.
So why don't you describe what is Moment Energy's role in this second life market?
Yeah, so we're lucky to say that we're one of the few companies that actually does the repurposing. So like we create the product from the EVs. So to talk about the whole value stream, typically when the EV reaches end of life, and the countries that we can really look towards are for example, Norway, where half of all vehicles on the road are electric already.
Yeah.
They're really where North America will be another, let's say, 20, 30 years, right? And, so, and then in Europe and in Asia countries, a lot of the EVs have already reached end of life. And what typically happens is in those countries, it's already mandated by law that the automaker has to take responsibility of the end of life EV battery. So the consumer
In Europe, you're talking.
Yeah, half of all EU countries, especially.
Yeah, well, it's coming here. We'll touch on that in a bit here, because it's probably coming to BC as well.
Exactly, yeah. So with them, the automaker then says, okay, consumer, just send the vehicle back to the dealership. The vehicle is then sent to the dealership, and so that the consumer doesn't have to pay for the recycling or anything like that. And then they will send the vehicle and the battery to the end-of-life facility. And what they'll do is they'll take the battery from the pack bottom of the vehicle, so at the pack level, and then within the pack, depending on the automaker, so Nissan might have hundreds of modules, and the Nissan Leaf modules are quite easy to Google for, but they're like laptop size for the first couple of generations. But the European ones, they're more like table type size modules, and there may be 7 of them in a whole pack. So they will disassemble it at the module level, and then they'll test. And when they test the batteries, they'll say, okay, these ones are good for repurposing. These ones are not good. So the not good ones, they claim that they recycle, and hopefully they do recycle, especially for the environment. And then the good ones are sent to Moment. And at Moment, we essentially will take in, the science shows that you can use any battery that's above 50% state of health is the guideline for repurposing. But we have a pretty big supply, an overwhelming amount. So
you don't have a shortage then for batteries?
No. We have like hundreds of megawatt hours of batteries that we don't know. We don't have the facility to essentially manufacture for her. And that's the next stage of our company, essentially, to commercialize faster.
Right. So are they stored at your facility in Port Coquitlam, or are they off-site? Or?
Yeah. So essentially, we order them. The automakers are holding onto them right now, and then when we have already deployed a bunch more projects and our inventory of batteries are getting low, then we'll ask for the batteries to be sent to us. So we do store an inventory of batteries, but not the whole hundreds of megawatt hours.
So how does this? So what are the dealers that you do buy from right now? Are you buying from all the OE manufacturers?
So we're only paying some auto manufacturers for batteries. Some of them are giving the batteries to us completely for free. So like Nissan and the other OEMs that we're working with that do the testing and disassembly, we are willing to pay for them because one, they ensure a certain standard, right? Like we tell them don't give us any batteries below 80% state of health. They'll ensure that. They will disassemble from the pack level to the module level. That's costs that we would have to incur ourselves otherwise. So we would also be willing to pay for that as well. And so we. That's kind of how it works, but there are some automakers where they'll send the battery packs directly from the dealership to us. They don't do testing, they don't do disassembly, and that's when we get the batteries for free, altogether.
Yeah. So what you do is you take the individual modules and you build a wholly separate pack out of that.
Yeah, so one of our units is 60 kilowatt hours. So what that essentially, in perspective, is a Tesla Powerwall is 9 to 14-ish kilowatt hours. So 60 is already pretty high compared for a residential home. Now, what it looks like is it's about 1.5 meters tall, a bit over 1 meter wide, and then depth is about, probably 50 centimeters-ish,
Yeah.
a couple feet and a half is the general guideline. And yeah, that can power, so for example, we deployed off-grid residential projects across Canada already, and each one of them are 20 kilowatt hours. And so we can already power, 3 of them pretty easily with one of our building blocks. And we can stack them up into larger and larger systems.
So what is the so obviously getting a hold of the battery is not a problem. You have a whole storage facility of them. What's the market now for that? Is there a huge demand?
Good question.
Just a matter of you.
For Second Life, there are 2 types of players out there. We're one of the main ones that actually have such a diverse array of suppliers and partners, while other companies would only mainly be working with Nissan. So we build flexibility. We're able to take in batteries from any auto manufacturer is the key, because we don't want to be supply constrained. Now, there is a high demand for Nissan Leaf batteries, not only just from companies like Moment, but also there's a whole do-it-yourself market out there where.
Well, yeah. That's so I will touch on. I do want to get to that, to the do-it-yourselfer. So is there a high demand, or is there a lot of Nissan Leaf just because are these the first generation batteries that they're now out of warranty and they're being taken back to the dealer?
Exactly. Like the Nissan Leaf vehicles have been on the road for like over 10 years now at this point, and majority of them have reached end of life. Especially since Nissan Leafs, the first 2 generations, the cooling was not super great in the electric vehicle. The batteries degrade much quicker overall. So majority of these owners have been just trading in their vehicles or getting rid of their vehicles. Now there's a high demand as well because now it's not just industry, kind of like we were just saying. Now there's also the consumer market that is also trying to buy batteries from eBay.
Well, there's a lot of them. This is the do-it-yourselfer, and it's not just that. It's in the salvage yards as well.
Yeah.
So is there do you see a potential for the salvage, for the vehicle dismantlers then, as also playing a role in that supply chain?
I think it's possible. There's definitely some hurdles there. So the very first, we're very thankful to like local salvagers, for example, because our very first battery pack that we disassembled and we deployed were from a local auto wrecker. And we just bought the battery pack from them. So that's also how we learn about pricing and everything for the battery. And how if we go to direct to Nissan themselves, not only have they done all that testing and disassembly, like the prices are better as well. But with the auto wrecker, you just get it at the pack level. So you're going to have to do your own disassembly.
And your own testing, because right now they're not testing.
It's a black box. Like you don't know what the quality of the battery is, essentially.
It's sort of as is. Yeah.
So you pay for something that you're not sure of. But there is... now, the main hurdle with auto wreckers taking responsibility and then maybe reselling it is that you need, for a company like Moment, who will then take in the batteries, buy the batteries, and then repurpose them, we need certification, essentially. And we need, and to get that certification, you essentially need, how was that battery manufactured even before it went into the vehicle? And the auto wrecker won't have that information. Typically, the people that has that information is the automaker themselves. Like the dealerships don't even have that information. It's the automaker corporations that will have it. So it's going to be very difficult if we today will go to an auto wrecker and buy the battery pack. It's going to be hard for us to commercialize that. It's commercializable if we deploy it in some off-grid settings where maybe it's a off-grid homeowner and they own their own grid. Then it's fine, sure. Like they can say, I don't need that UL certification stamp or safety certification stamp. I'm okay with that. But if you ever have ambitions to, we can install batteries into this building, and then for BC Hydro to not be mad at us, you need that UL certification stamp. And it's pretty hard for you to do that if you're buying from auto wreckers.
So how big of a problem do you think this will be, especially as the do-it-yourselfer market grows?
Yeah.
How about that guy who, well, he has the summer home or the summer cabin, and he's hooking up his batteries up to his solar panel, and hopefully he knows what he's doing. Yeah. But as this grows, just your common person thinking, I'm just going to create a storage shed in my backyard. Yeah. How big of a problem is this? And do we need regulation enforcing that certification or some kind of an oversight in this whole game?
That's a really good question. So we're actually a part of the DIY Powerwall is what they call them, Facebook
Yeah.
groups. And
Yeah.
that's how we found our first couple projects too. Now, those groups, they're very intelligent, which is awesome. Like, for example, even just a community of a couple thousand, like they have a lot of great technical expertise, and they also advise each other, like, hey, what you have in your shed, like some people like to take pictures of the systems that they made, and then a lot of them will pounce right on that and say, like, hey, you're missing like a battery management system. And the battery management system essentially controls the charging and discharging of the battery for safety, right? That's why your phone has one or a laptop has a battery management system. So I'm very glad that group exists so that they can advise people saying, like, hey, you're doing something very unsafe right now. Now, technically what can happen, though, is it's very hard to regulate off-grid individuals because a lot of these off-grid individuals typically want to move to the middle of the woods or move to the middle of an island for a reason. They don't like to live in like an urban area, and they own their own assets, right? They own their own house and all that. So the main negative of installing an uncertified battery pack or doing it yourself is that you just got to be comfortable that you're voiding any insurance if you do have insurance, and that there's a good chance because maybe you are a DIYer who's not an engineer that shed could potentially catch on fire, which will happen again if you don't have a battery management system.
Or someone's just going to get electrocuted.
Yeah,
I mean, we are dealing with extreme high voltage in some of these batteries.
Well, exactly. So that's why we definitely highly encourage people to come to professionals, which is why I think we were very well received when we just joined these groups and we're like, hey, anybody want us to handle the repurposing for you guys? And like a lot of people might not have the technical expertise to repurpose EV batteries, but then now they trust us to do it for them.
Right. So primarily you're just in the commercial batteries, but you potentially see a market in advertising, hey, let us install a battery pack in your home or your sub cabin.
Yeah, actually some background is over the past couple of years, we've already deployed 3 off-grid residential projects. So it's literally, going on Facebook back then. As a startup, you're pretty scrappy, and you say, hey, anybody interested in a 20 kilowatt hour system? And for them, a lot of people were interested because, the current solution within off-grid DIYer type individuals is that they have lead acid batteries. And the problem with off-grid is that they draw a lot of power, and they will also use so much energy that they'll cycle the battery every day. So in other words, one cycle is one full charge and discharge is one cycle. And lead acid battery has only hundreds of cycles in it. Let's say 300, 600 cycles in it. So if you cycle it every day, the batteries, although you're promised 10 years of life, will only last a year. Or worst case I've heard is due to drawing too much power from the battery, they damage it so much that it only lasted a month. Now, that's where lithium batteries really are great quality for that because they have tens of thousands of cycles. Plus, they also have very high discharging and charging capabilities. So it's very suitable for this off-grid market. Now, the reason why now we've moved more into commercial away from the residential is mainly it's just like startup business type work. It's scalability. When you're a business and you're trying to create the same product rather than a custom product per home, but you're trying to create the same product that's scalable, it's much easier to do that in the commercial industrial market rather than in the off-grid residential. Because in the off-grid residential, we have had to tweak some things of the battery because, some people use diesel, some people use only solar, some people use hydrokinetic energy, or some people install kilns in their off-grid homes. And
So how long will your repurposed batteries last?
Good question. So of course, it definitely depends on how often you're cycling it. So for example, what we warranty for is 7 years, which is pretty standard in the commercial industrial space. It's between 7 to 10. And why we're comfortable at warrantying 7 years is because, for example, Nissan has done their own studies. So they've taken a 60% state of health battery, which is on the average of 80 is on the lower end, right? And they took off-the-shelf new lithium, very non-intelligent battery management system and plugged it in. And they cycled the battery to death, essentially. And they got about 7.5 years worth of cycles on it. So that's why we're extremely confident in, just because the batteries that we're deploying are 80, 85% state of health, so we can warranty for 7 years. But then it depends in the sense that if some applications don't cycle the batteries every day, right? Some applications will cycle especially in commercial and industrial, you can actually cycle it 20 times a year for you to get the most utility bill savings, for example. And that's just a whole rabbit hole. But.
So as a consumer of this product, of the repurposed battery, just like with my vehicle, how do I know what the state of health is going to be and when it's done?
The consumer can't. There's no good way for the consumer to know. Unfortunately, it's the automakers that are able to do a lot of extensive testing to find out. But also, there are other companies out there that we know of that will do testing, and what they're trying to do is trying to plug in to the vehicle and help consumers determine the state of health of the battery.
We can do
for
that.
The used market.
We can do that with vehicles. How about with a repurposed battery, though? So I purchased a battery from Moment Energy, and it's for my cabin or for my business or whatever. How do I test that? Like, when do I know that it's beyond its warranty period? Its state of health is really depleted.
Yeah.
Is it just that my lights won't work after a while, or nothing comes on?
Yeah, good question.
How do I know this?
So with our product, we definitely have dashboards and everything that will keep the customer. One is most important is state of charge, right? Like knowing how much battery or energy you still have left, and if you're taking in solar energy, diesel energy, like we have the dashboards there for it, and through our calculations, we can determine the state of health for you and let you know. Though the consumer typically, it doesn't really matter to the consumer too often what the state of health is. Typically, the consumer, just like an EV vehicle, they just want to they care about the state of charge, or how much is the maximum state of charge. So for example, what that equivalent is range in a car, right?
The range anxiety, which people have in a car, is there an equivalent to that for battery storage?
So probably less so, mainly because if, for example, the storage reaches, has lost capacity in the stationary storage application, it just means if we're serving a utility bill, that we serve it a little bit less in terms of energy. Or when we're dispersing that energy into the building, we just tell the customer, hey, we can only take in, before it was 70 kilowatt hours of usable capacity. Now it dropped to 65 kilowatt hours after all these years. And the customer doesn't really care about that. So it's more of a moment issue. If the capacity decreases, that essentially just means that, hey, we need to either replace this battery or we need intelligent algorithms to help with the customer's problems.
Yeah. Can anyone buy a repurposed battery? Could I go to Moment Energy and show up your front counter and
you could
buy batteries?
You technically could. Now, for example, we typically get the question how about data centers or backup power? Could we just buy your battery for backup power? And we say, yeah, sure, you could. If Amazon decides to buy, hundreds of millions of dollars worth of our batteries for backup power, we say, sure, but the thing is, we personally, as engineers, we think that's a little bit of a waste for that application, because backup power, maybe Amazon's data center gets out of has a blackout for 15 minutes once a year, right? And again, EV batteries or lithium batteries typically have tens of thousands of cycles. So if you're going to only cycle it once a year versus you have so many cycles, it's probably better value for that customer to use the battery for an application that will cycle the battery a lot.
Yeah. So we have to move away from fossil fuels. We have ambitious targets. I think it's 2050. But there's an abundance of power. The sun, I think what is it on a continuous? It's at 173,000 terawatts, which is more than enough than what we actually consume on a daily basis. And then there's hydro and there's wind. So obviously, the problem is capturing that. We need the solar panels, but then storing it. Do you think by 2050 we'd be able to produce and mine enough lithium to be able to build and manufacture enough batteries that there could be a battery pack in every home and every business?
Great question. Yeah. So to address actually the first part, we definitely believe that it takes a village. There's many different types of energy storage as well, right? There's lithium is what we're focused on, but even for us, we do plan on branching out to many different chemistries as well. For example, zinc batteries are popping up, solid state batteries are popping up. You start hearing about air batteries as well, and
graphite.
And graphite, exactly.
Graphite now,
And we believe that each battery has its own best use case. So for us and lithium batteries, the best use case is what we call a short duration market. So short duration means if you need a lot of power in a short amount of time, lithium is the best by far compared to any other energy storage. It's the best. So typically, what that means is a typical lithium battery can fully discharge, from 100% to 0 in 4 hours. Right? That's decently fast in the engineering world. For us at EV batteries, we're aiming for that 1 hour, so we can discharge even faster than traditional lithium that's being used for buildings. Now, but then when you have zinc batteries, they're really great for that 10 to 20 hour application, right? So like when you need to slowly discharge over the entire day rather than a short amount of time, and then you have bigger and bigger batteries like again the air-type batteries where they'll discharge over days and whatnot. So we believe that 2050 we can, with a combination of all these differing energy storage, it's possible. One hurdle, though, at least for the lithium side of things, is all the battery material is going into EVs. They're not going into stationary storage.
We need EVs.
Yeah.
The EVs are the priority.
Yeah. So because of that, which is great for the decarbonization of transport, it's not great for now commercial buildings like this are begging for energy storage, right? But then they just can't buy it. So right now there are many companies that have announced, like the new lithium providers, they buy batteries just directly from China. There's not too much innovation there, and they just make large new lithium energy storage systems. They're sold out for the next 3 years, which is where we're also seeing the opportunity. Where by 2030, it's projected that there's going to be 200 to 300 gigawatt hours of end-of-life EV batteries per year of supply. So now that all of that lithium material and battery material is going to EVs, we can now divert that finally into stationary storage, and then for another 10, 15 years, and then once that reaches end of life, throw that into recycling, and then hopefully that goes back into EVs or any other type of energy storage.
So are batteries the only way to store power? So I have heard some ideas, and I don't know how far-fetched they are. So one is a hydraulic method. So we have two pools of water, and of course, when there's excess power, it pumps the water into another pool, and then when you need it, gravity just takes it down and spins the turbines. Yeah. And then there's these big towers, and again, when there's excess power, they raise these huge weights, and of course, when you need it, then you drop the weight. Are these just really far-fetched ideas? Or
So actually, I like both ideas. The gravity-fed ones, essentially the ones with the huge concrete columns, that has a lot of hurdles, mechanical hurdles to that. And there are a lot of more simpler ways to do it, but I'm certain that the engineers and innovators that are working on that have their reasons for why they think that that's the best idea. And one idea for the gravity-fed one is you pick up, when there's a time of excess power, you pick up these concrete columns and you keep stacking them into a tower, right? Or the opposite can happen where there's actually a huge underground tunnel, same with concrete tracks and everything, and you can bring, when there's excess power, you just bring the weights back up, and then when there's power needed, you then let go, and then it'll slowly, due to gravity, drop back down. There are innovators there. I don't know how far they are along there. Seems interesting.
It always sounds good in theory.
Yeah, but the water one, hydro. It's called pumped hydro, and that's actually been in place for a while now. So it's been pretty cool. Like for example, on Vancouver Island, there's a camp called Strathcona Lodge and Park. I actually used to go there when I was in high school for summer camp too, and I only just realized that they actually had a federal project that had created pumped hydro. It was exactly the same thing that what you just said. So they have 2 ponds. Now there's variability there though because they're ponds. So depending on before that summer, when they do use the power, how much rain actually filled up these ponds is actually how much of usable capacity they can transfer from this higher pond. And like you were saying, water, when they need power, water will flow through. There's a little turbine at the bottom, and then it'll power the facility. And then once there's a lot of power and they have solar, they'll pump it back up through gravity. I think that's interesting. And yeah, of course, there are challenges there, right? Because every year you actually don't know how much battery capacity you have, but I think that's been pretty well established already. Yeah.
Well, the optimism for the repurposing of batteries is that it takes the stress off the peaks, the peak usage. Because a common thing that we hear it a lot on the EV-friendly channels from the so-called skeptics, is we can never have a fully electric vehicle fleet because the grid can't handle it, can't deliver enough power. But I've read actually that batteries can solve a lot of that because it's about evening the energy out.
Exactly. Yeah. So that's exactly what Moment's doing, especially with our on-grid type projects. So what we're really targeting for on-grid is manufacturing, commercial industrial manufacturing buildings, EV charging infrastructure, commercial buildings, and throughout Canada, especially in Ontario, Alberta experiences some of this, but Nova Scotia, and then in the U.S. it's the entirety of the East Coast, Texas, California, Nevada. They essentially, the peak demand charges happen, and what that means is typically they're daily peaks where there's typically a couple hours in the day around 5 or 6 p.m. when everybody's home from work and they turn on their TVs, they're cooking dinner, and they draw a lot of power. So the grid is the most stressed around those times, and that's why if we look at our utility bills, if you use a lot of power during those times, you're going to be charged more. Versus if you use power at 3 a.m., nobody's awake, so then that's the best time to, I guess, charge your EV or run your dishwasher.
Right.
Now, there's an even greater problem called global demand charges. So rather than just within a day, it's just throughout the entire year. So in Ontario, for example, they have this phenomenon called the 5 peaks. And if you draw power during a 2 to 4 hour interval as a commercial industrial building during one of these peaks happen because the utility grid's like, oh my God, like we're about to black out because so many people are using power. They will charge you hundreds of thousands of dollars in utility bill fines just to try to disincentivize you from drawing from the grid. Mm-hmm. Now, what we can do is, because these peaks last for 2 to 4 hours, right, or even shorter sometimes, 1 hour, we can install a battery into a manufacturing building. Mm-hmm. And so then, therefore, when a peak shows up, there are currently software systems that will predict when these peaks will come up. But the problem is prediction only goes so far because they say, hey, a peak is coming up. Mm-hmm. And they're like, well, what am I going to do, turn off my facility for 4 hours? Right. So they can't do that. So that's where our energy storage comes in. And we can allow them to totally cut off from the grid, and we can discharge our batteries so that they can maintain operations while they're also not incurring these huge utility fines.
Right.
And that's exactly, for example, we just secured a project with Ottawa Hydro. Mm-hmm. They bought 4 of our battery packs for that exact problem, charging electric vehicles, where in one neighborhood, when the first thing is apparently when one neighbor buys an EV, like I don't know the exact stat, but like it's hundreds of % more likely that your neighbors will start buying another EV as well, and everybody's following suit. And when a neighborhood, there are 10 people all charging their EVs at home at the same time, that neighborhood grid is also about to black out. Right. So it's because the current transformers and infrastructures can't take that high power draw. So for Ottawa Hydro, rather than spending millions of dollars in uprooting the transformers and the current infrastructure, they spent a couple $100,000s to install a couple batteries to, again, during when everybody's charging their EVs, we can also discharge our batteries so that we can supplement the grid.
Yeah, so there could be a lot of application for these in parking lots, and because when the power goes out, and if it goes out for a long time, and one of the criticism is it's not like gas where you can still fill up on gas, you're stuck. Yeah. But if we have that secondary power storage at EV charging stations.
Yeah, exactly. And additional benefits. So, for example, EV charging stations, same deal. Like when they're drawing too much power from the grid, they're going to get charged these utility fines as well. And then if you're an EV charging company, you lose all your revenues, essentially. It's very hard for you to make any money at all. Another phenomenon that batteries can help with is DC fast charging. So, for example, when you're charging, like when I'm charging my EV at home, I just use the 120 volt outlet outside, and it will take, it says sometimes 24 hours to fully charge my EV because it's very slow. So that's level 1 charging. Yeah. And then level 2 charging is when you have 240 volts, and you can then charge your entire EV in 4 hours, right, or 6 hours, which is great. But then for you to get that level 3 charging, where you charge in 20 minutes, kind of like a Tesla supercharger, that's when you can actually use DC fast charging. So the reason why it's super slow for level 1 and 2 is because you take battery energy, right? Let's say, so it's DC energy from the battery, right? But you have to transfer AC energy from the wall, which is an alternating current, into DC energy. So that has a lot of power losses as well. And then, and then imagine you had a battery on site. So you have a battery that's DC, discharges, converted to AC, so that it's wall energy, and then you convert it back to DC, right? That's very inefficient, and that will cause a lot of time in terms of charging. But if you imagine you just hooked up one battery to another battery, so DC to DC, there's nothing in between. That's how you can really charge in 20 minutes. And
So that could be an application everyone could have DC charging at home with.
that'd be cool. Yeah.
Yeah. Because currently you're restricted to just a level 1 or level 2.
Yeah, exactly.
And nobody has DC fast. That's interesting.
Yeah.
So BC has really come out ahead in the EV market,
Yeah.
and we're leaders. I actually get a lot of phone calls from a lot of government and NGOs alike, and they're looking to BC. I was like, well, how can we build a program here for our local area? Did that influence you of where you were going to set up shop?
Great question.
Or is it just because of our great weather?
It's probably because of great weather, honestly. Well, it's like the talent, I think. For us, why we started in BC is it is the ecosystem in terms of clean tech. There's definitely a lot of work out there that needs to be done. For example, the utility is not super progressive when it comes to taking in privatized renewable energy. Like a lot of times our utilities like to do it themselves, while others like out in Ontario, Alberta, and everything, they love privatized renewable energy because they believe that we just need to create that ecosystem. But what's awesome is the talent here in BC.
Yeah, well, let's talk about that. What because I go on your website and you're all engineers.
Yeah.
Is that the level of talent that you need, or could this work into a manufacturing process where it's a trade, or 2 years of a technical college specialized in just this? How do you see this playing out? Yeah,
that's actually extremely possible. So currently we're a team of 28. I think I kind of mentioned earlier, and
you're all engineers?
No, not all of us are engineers. Yeah, so a lot of us are, and we're all from like local universities. UBC, SFU, UVic, even BCIT as well. And for us, there are many different strands. Like they're not engineers, not just engineers, but also business development individuals. We hire from solder, BD. It doesn't really matter, as well as technicians. So we're really trying to build a manufacturing ecosystem here in Vancouver. Although many people, Vancouver doesn't have a great rep in terms of trying to manufacture locally, but we're trying to beat that I guess stereotype. So we're hiring a lot of manufacturing staff as well locally in our Port Coquitlam facility.
Interesting.
These are individuals that, maybe they did go to a specialized school, like a 2-year course at BCIT for battery technology manufacturing, or they don't actually have to even have worked in battery technology, but they just have a really good track record in terms of electrical or mechanical type assembly and work.
Could somebody with automotive experience who is used to working on EVs or has experience, do those skills translate?
Absolutely, yeah.
Okay.
Yeah.
Not that we don't want you to steal, because we're having a hard enough time attracting labor into the automotive service technician. But that's interesting. So you mentioned about Europe, and I know Europe is very big on extended producer responsibility, or EPR, and as you know, that's where the producers are responsible for that end of life. Do you see that as being help or hindrance here in BC when it comes to Second Life?
Good question. So if we implemented that in BC as well, we do. I mean, so far, especially with our partners in Europe, we see it as a help, mainly because we don't want to take the whole go to an auto wrecker and taking in all these batteries, doing our own testing, and trying to find a path that way. We prefer to work with the automaker, and we see that when the automaker is responsible for the EV batteries, that they're typically going towards Second Life rather than just recycling, for example.
Would you want to see working with the auto dismantling industry if they had a program that they could do their own testing and have some quality assurance?
I think it would be extremely helpful.
Yeah.
The main hurdle for that assembly, for us to be able to repurpose their batteries, is if they got UL certification there, which is what we're working on.
Okay.
Now, that doesn't mean that maybe they don't want to work on UL certification, right? And to talk about a little bit of that, what's required in UL certification is the testing, sorting, and grading of batteries once they reach in a certain facility, the manufacturing process, and then once that's all been approved by UL certified process, then you have a certified product that you can hook onto the grid. Right now, we're actually aiming to be the first in North America to ever get the certification. So we are handling a lot of that. But if there are partners that will take, let's say, ICBC, that's actually difficult. Let's just say, take end-of-life vehicle batteries and dismantle it for us, at least, and take away that headache, then I think we'd definitely be good there if they didn't want to do the whole UL certification.
Well, it might be very onerous for a smaller recycling facility to go through that process. But could there be like a UCL Lite that could be incorporated into our own EV-friendly certification that would meet the standards and be practical for those facilities to attain?
Maybe in terms of that, it's if the facilities are able to do testing on the batteries, for example, just determine state of health. I mean, the easiest thing without needing to go through the whole UL process is probably, and that's useful to a company like Moment, is at least tell us what the state of health of the battery is.
Yeah.
And then that stamp could technically be, this battery's above, hey, Eddie, this battery's above 70% state of health. Do you want it? I think that, and then
exactly.
It has that stamp.
And then it's worth 70%. It for you to purchase and go pick it up or to transport it, which is costly as well. Yeah. So with EPR, one of the criticisms from the dealers, the OEs, is, look, we'll accept EPR. We built this battery for use in a car, but why should we be held responsible if it's taken out of the car and used for a battery pack?
Good question.
So if we had EPR, is that something then you could say, okay, OE, I'll take it from here. I'm responsible for the battery from here end?
Yeah, the answer is yes, yeah.
Okay.
Because right now where the dealerships are, that we know are talking about is they essentially don't even want to recycle. They just don't even want to take that battery back in because they know it's a liability to the dealership and or, I guess, corporate insert automaker name. So for us, that's exactly what we do. We say, just send us the battery and we'll take responsibility of the battery. And they love that because then they're off the hook for that couple $1,000 recycling bill as well.
Yeah.
And they don't actually have to worry about, to them, they don't worry about, if the battery's going to get recycled or if the battery gets repurposed. It doesn't matter to them. It's just out of their own hair at this point.
Yeah, for sure. Let's talk about some final thoughts.
Yeah.
Where are we going to be in 5 to 10 years in terms of, is every household going to have a battery storage? Are we even there yet? A percentage?
Good question. In the next 5 years, honest answer is probably not. That would be a great dream in the next 10 years, probably, where every single home has their own battery, and it's like distributed energy, right? Then even provinces that are not BC, but provinces like in Alberta, for example, what they can do is arbitrage, right? Where you have your own solar panels, you have your own battery, you store power, and then when the utility is like, oh gosh, guys, it's 5 p.m., everybody's using power. And you're like, well, I got power in my battery pack. I'm going to start discharging my battery pack onto the grid. Then you get a bill. And people say, and then the utility says, here you go, you just earned money. I think that'd be a cool way to for consumers to, one, buy and sell energy, but also, two, is reliability, right? Power outages won't happen anymore. And then all these other benefits, like charging your EV extremely quickly, are all different possibilities. Where we see, for example, for us in the next 5 years, our goal is just to deploy, a gigawatt hour of end-of-life EV batteries as second-life batteries into commercial industrial facilities, where now the grid actually has a bit of an easier time with all this power draw. Because when I mentioned, there are 5 peaks or 5 times in a year where people are drawing too much power and the utility's charging hundreds of thousands of dollars per occurrence, it's only going to get worse. If we stay stagnant, we didn't try to solve this problem at all, there's going to be a 6th peak, a 7th peak, an 8th peak, right? And for us as a society, we're just drawing more and more power. So one way to help us continually progress as a society, have power at our demand and really not overstress the grid is to have distributed energy storage for sure.
Right.
Yeah.
So in terms of your company, Moment Energy, where do you project you'll be in 5 or even out to 10 years?
Yeah, for
Quite
sure.
a long time, but
Yeah, yeah, for sure. So the next 5 years, our goal is to hit a gigawatt hour worth of energy storage, which is huge. It's a lot amount. For example, New York is asking, I believe, for 2 to 3 gigawatt hours.
so you'll need a lot more engineers.
Yeah, we'll need a lot more engineers. We'll be expanding for sure. Like, kind of like you were mentioning, we really love British Columbia. So hopefully, especially with the additional support from the government and whatnot, we want to create that ecosystem. You know, Microsoft has Seattle. We want Vancouver to be our champion municipality and manufacturing. So our goal over the next 10 years, so by 2030, is to make sure that every single battery is repurposed. Usable battery is repurposed from after the EV. And how we do that is, it might not necessarily mean that we're the ones directly remanufacturing these batteries, but especially with the technology that we can license out, we can enable more companies to repurpose as well.
Right.
So we can all be manufacturing.
And you see a lot more players coming into this
Yes.
space in the coming years.
For sure. I mean, again, 200 to 300 gigawatt hours a year of end-of-life battery supply, where like a single recycler can't handle it, a single moment can't handle it. It's going to be a huge market.
We're really at just the beginnings of a huge new industry.
Absolutely.
Obviously.
Yeah.
Absolutely. So if somebody wants to learn a little bit more about Moment Energy, are you going to be up at the BCIT Evolution event in September?
Good question. Maybe.
Okay.
Go reach out to them. For us, you can find us at momentenergy.ca or momentenergy.com.
Okay.
We're constantly hiring. We're hiring more technicians, engineers, a manufacturing lead, are all aspects. We're also, you can find us on our socials like LinkedIn.
You Facebook as well?
Yeah. Facebook.
I'll check you out and search for us for EVfriendly for our YouTube and Facebook.
Yeah.
Eddie, it's been a great pleasure talking with you today.
Yeah, likewise.
Thank you for coming on the podcast.
Thanks for having me.
Thanks. If you've enjoyed today's podcast, please check us out on the EVfriendly Facebook and YouTube and like and subscribe. And for those that can't watch a full podcast, check out EVfriendly on the go, our audio podcast available wherever you download your podcasts. Thank you.